Hi there, and we are now on the last operation, finally in the algebraic expressions. Okay, so we're done with the addition and subtraction. You can um, search for that in my channel. We are done with the multiplication. We have dedicated one video for that, or one separate video. And now we're going to be dealing with division of algebraic expressions. Okay, so be with me, and this is gonna be a little bit of bumpy ride, but bear with me. I will teach you very clearly how it is done. Again, just like in our multiplication, we'll do that one by one so that you will have the picture of how to do it. Okay, one by one. So let's start with division of algebraic expressions. A monomial is divided by a monomial. Okay, pretty much like this. So what are we going to do? We're also going to use one law of exponents. This law is called the quotient law, or the law of quotient. This law states that if you have an x, for example, x in the numerator and then an x in the denominator, and this x has an exponent a, and this denominator has an exponent b, what happens here is that you copy the x. This x is any variable, okay? Provided they are the same, and then they have different exponents. What we'll do is we're going to deduct the exponent of the denominator from the exponent of the numerator. Okay, so it's gonna be a minus b. Recall in our multiplication, we are doing the similar thing, not really the same thing, but we're doing the similar thing. If it's a multiplication, what we're going to do is we're adding the exponent. So this becomes x raised to a plus b. But if we are dividing, so we're doing the subtraction. And we're going to apply it here in the rest of our video for division of algebraic expressions.
It's 10 o'clock.
And then we're going to divide it here and the rest of the video for the division of algebraic expressions. So we're going to start with the numerical coefficients. So minus 10 divided by 2. So I think that's pretty much straightforward. This is arithmetic. Minus 10 divided by 2. 10 divided by 2 is 5, right? So it's going to become 5. Let's make this blue since it will denote the answer. So this becomes 5. Okay, and then by the laws of operations of signed numbers, we have a negative numerator and a positive denominator. Since they don't have the same sign, so it's going to become negative for sure. Okay, and then let's look and move on to the x's. Okay, so x to the fourth o minus x over rather sorry x, we're going to copy x. Okay, x, so let's make it that way. Okay, x, so the numerator is 4, the denominator is 2, so it's gonna become 4 minus 2. Okay, and then how about the y, copy the y, we have 3 and 3, it's gonna become 3 minus 3. Okay, and how about the z is going to become 2 minus 4. Okay, and then we're also gonna need to have some review for the loss of exponents, so bear with me. So this is our answer. Okay, next line, we need to copy the minus 5 because it's gonna be still we cannot do anything with the minus 5. So we have x raised to 4 minus 2. So 4 minus 2 is going to be 2, or squared, x squared. Y raised to 3 minus 3, y would be raised to 0. And then z will be 2 minus 4. So big number minus small number, that's gonna become 2. Copy the side of the big number, so it's gonna become minus 2. And we will be recalling some laws of exponents here. One law will tell us that any number x, I will put it here, any number x raised to 0 will be equal to 1. Okay, any number raised to 0 it will be equal to 1 for all x. X should not be equal to 0. Okay, for all x not equal to 0, because if x is equal to 0, that's gonna become 0 raised to 0, and we don't want to talk about that in this video. Okay, maybe in calculus we can talk about it, but to tell you, that is undefined. Let's put it simply as that, undefined, but that's a very technical term in calculus. Maybe there will be someone who will be a calculus major here, or a math major that is interdeterminate. Or okay, so okay, let's not talk about that in this video. Okay, so the thing is, 0 raised to 0 is bad for our health. Okay, so let's not do that here. So it should not be 0 raised to 0. So it could be any number raised to 0. So here we have y raised to 0 is equal to 1. So it's gonna be simply gonna vanish out of thin air. Okay, so next up we have z raised to minus 2. We also need to have some recall for the laws of exponents. If we have an x which is raised to a negative power, this is equal to, and remember, we cannot express anything by negative integers or negative powers, rather negative exponents, because that is also somehow illegal in writing. So we should get rid of the negative sign. How do we get rid of it? We put the terms in the denominator, so that we get rid of the minus sign. Again, x raised to any number which is negative will be 1 over x raised to any number which becomes positive. So we just simply put it in the denominator sign. So we're going to apply these two laws in this last line. So if we're going to apply that correctly, it'll become minus negative 5x squared. Y will vanish, but z will be transferred in the denominator. Z squared. Okay, we transferred it in the denominator so that we can get rid of the minus, the negative exponent. So this will be our answer for monomial to monomial. Okay, monomial to monomial. I hope you got it right. Again, if not, you can always rewatch this video. Okay, next up in our list, just like in the multiplication, we will be talking about polynomial by polynomial. Okay, so how do we do this? Okay, so by polynomial by monomial rather. Polynomial by monomial. So there is 1 here in the denominator, and there are pretty much a lot of things in the numerator. So what are we going to do? We're like going to separate this denominator here and put it, the thing in our heads is we're going to distribute it here in this term, and then also in this term. Okay, so how do we do that, sir? So imagine these terms to be something like this, written like this. So copy this numerator, 15 x to the fifth y cubed z squared all over minus 5 x y z. Copy this sign here. This is a negative, and then 10 x squared y z cubed all over negative 5 x y z, plus, copy this sign, plus the last one, 5x y squared z squared all over negative 5x y z. Okay, and pretty much we will apply the rules we have learned in the previous slide in the monomial by monomial, and pretty much do the same tricks. Okay, again, let me write the law of exponent we have used. Remember, x raised to a all over x raised to b is equal to x raised to a minus b. Okay, so let's apply it here. So this becomes, for the first term, 15 divided by negative 5 is equal to 3. But since they don't have the same sign, so it's going to become negative 3. Okay, x, copy the x, and we have 5 minus 1. Let me put the 1. 5 minus 1 is 4 by this law. Then y cubed minus y raised to 1. Okay, or rather 3 minus 1 for the exponents. It's going to become y squared. And then z squared divided by z. So imagine there's a 1 here. So 2 minus 1 is simply 1, and we don't need to write the 1 here. So this is for the first term. Okay, this is for the first term. For the second term, we have 10. Let's copy the minus sign. Okay, 10 divided by 5. 10 divided by 5. So we have 2. But since they don't have the same signs, it's going to become negative 2. Okay, negative 2. So we will be fixing the signs later since we have a negative negative. Maybe we'll put that in the parentheses first so that we can discriminate this negative sign from this negative sign. Okay, and then we have simply x. So 2 minus 1 is 1. We don't need to put any variable, any exponent there. Y divided by y. So y raised to 1 divided by y raised to 1 is going to be y raised to 0. By our law in exponents that states that, let me put it here, any number x raised to 0 is equal to 1 for all x not equal to 0. Okay, so it should be that x is not equal to 0. So to put it here, so we can just just cross out the y for that, and it'll become 1. And then z cubed divided by z, okay, will be z squared. Okay, that will be z squared. So maybe in the modules the key answer is quite wrong. Kindly correct that. It should have a z squared there. Okay, in the module. So let's put a close parenthesis here. Plus, okay, and then we have here 5 divided by 5 is 1, and since they don't have the same signs, it's gonna become negative 1. Let's put a parenthesis here also, so implying that we need to simplify it further, or to just fix the signs at least. So x over x, just like in this scenario, this will be cancelled. Y squared over y, 2 minus 1 is 1. Okay, z squared over z, 2 minus 1 is just 1, so that's gonna be simply z. Okay, and let's fix the signs here by the laws of removing symbols in our previous video. So how can we do this? In this first term, we cannot do anything but just copy it. Maybe we can fit it here. I'll try. So this becomes negative 3 3x fourth to the power of 4 y squared z. We have minus minus, so we have, imagine that there's a negative 1 here, multiplied by negative 2, that's going to become positive since they have the same signs, and then 2 times 1 is 2, so this becomes positive 2x z squared. And then we have a plus 1 here, imagine there's a plus 1, so plus 1 times minus 1 is going to become negative. So the answer is 1, but I think we don't need to write the 1 because it's understood that for all variables it has a numerical coefficient of 1. So we can just write yz here. And that will be our final answer by dividing polynomial by monomial. Okay, let me highlight that. Let me box that. Okay, I hope I made it very clear. Maybe in our module there's an error that I forgot to put the z squared. The z should have a square there. Okay, so kindly make the necessary changes.